Okay, so today we're diving into our first algebra lesson officially, and we're starting with algebraic expressions. So expression, when you express something, a feeling, you're showing something. It's the same thing in math. Expressions really are just a way of symbolizing and showing things. And what you'll find with algebraic expressions is that you're gonna have this letter that a lot of people are so scared of in math. Like, why are you introducing letters? Let's stick to numbers. We've always stuck to numbers, and now you're introducing letters. And that's what algebra is all about. So what is the letter? Like, how do we refer to the letter in math? It's actually called the variable. And so that's a term you should become familiar with. And it actually makes sense when you understand what the letter stands for and why we use it in math. So variable, the actual word variable, means something that changes, right? And actually in math, the letters that we use them because we're representing some unknown value or a value for something that might change, right? So you might have different values that could work in a problem, and you're gonna represent that using a variable, a letter, right? Because you can't put in a number. You might not know what the number is, or there might be multiple numbers that you want to be representing. So think of the variable or the letter as like a stand-in for some number. And the number outside, in this case, the 3, if we have the expression 3x, the 3 is what we call a coefficient. And so 3x, what does that mean? Well, math, of course, is pretty funny. We like to keep things efficient and shorthand. So, just as you might be using a shorthand way of writing something while you're texting, in math, we do that with multiplication. We don't always write the multiplication sign, and that's okay. If you're missing a sign, it's usually a multiplication value that you're omitting, right? To kind of shorten your expression. So 3x actually means 3 times x. 3 times some unknown value, right? That's really all this expression means. And so what are some examples of expressions? 2x is an expression, which basically just means 2 times x, 2 times some unknown value. You might not even have an x, you might have an a or a y, right? So here I have 3a plus 1, right? You can add other operations on top of it. Or you can even make it more complicated, like 2y squared plus 4y plus 7. So all of those are examples of expressions, and we're gonna talk a little bit more about when do we use expressions, why do we use expressions. But before we do that, let's talk about how to simplify expressions. So in order to simplify an expression or put things together, we have to talk about like and unlike terms, right? What are things that we can put together? What are things that we can't put together? And the way I teach this is by reminding my students of like PlayStation 2 and PlayStation 3. They're two different models of PlayStation, and sometimes the games that you have on PlayStation 2 won't work for the games that you have on PlayStation 3. They have different features. They're completely different systems that we can't actually put together. So they might start with PlayStation, that name PlayStation, but that 2 recognizes it as its own thing. And so this is basically saying that if I had p squared, I can't put it together with a p cubed or even a p. They're all different. One is a PlayStation 1, one is a PlayStation 2, one is a PlayStation 3. And so I'm here down below, I'm giving you examples of like terms. So 4x, x, 9x, they all have that same variable x, right? Below that, we have x squared, 2x squared. Again, x squared, the variable, is the same to the same power, so the power matters. Unlike terms, things that we wouldn't be put together, they're completely separate entities, would be like 3x squared and 2x cubed. It's kind of like 3 PlayStation 2s and 2 PlayStation 3s, right? You're not gonna say you have 5 PlayStations, you're gonna say you have 3 PS2s and 2 PS3s, right? So just kind of use that to help guide you with what you're putting together. And then x squared, and x to the cube are all different. So we don't worry too much about the coefficient. We're really looking at that variable and what power it's to. Okay, combining like terms. So how do we combine 3x plus 2x? Well, we know the variables are the same, right? Just x and x. And the way you combine them is by just adding the numbers on the outside. So 3 plus 2, you're gonna add the coefficients, gives me 5, and I'm just gonna keep that x. So 3x plus 2x is 5x. Just as if you were saying 3 PlayStation 1s plus 2 PlayStation 1s gives me 5 PlayStation 1s. Now 3x plus 2y, ooh, this is like completely different, right? They're two different variables. I cannot put them together. This already is in simplest form. That's like saying I can't say 3 PlayStations and 1 Xbox. I can't put those together. So 3x plus 2y is already in simplest form. They have two different variables. I cannot combine them. Okay, let's work on some examples and see if we kind of get this. So again, when you have the same variable to the same power, you can put it together by just adding or subtracting the coefficients. So in this case, let's take a look. We have 6a squared minus 3a squared plus 7. Great, so I see a squared. I'm actually gonna underline that for myself. I'm like, okay, I can put those together, right? They're both a squared. So that gives me 6a squared minus 3a squared. I'm gonna subtract the coefficients, and I get 3a squared plus 7. Now, I can't add the 7 because it doesn't have a variable, so that's also just standalone, right? You can't add the 7, you leave it alone. So that's how I simplified that expression. Let's look at a little bit more challenging where we have multiple variables. So now we have x squared, y squared, x squared. Okay, so I can put the x squares together, but the y squared one has to stay by itself. That 4y squared term is going to be all on itself. So let's focus on putting together x squared plus 9x squared. Well, again, if you just see x squared, there's actually an imaginary 1 there, right? You don't have to say 1x squared. So 1x squared, or just x squared, plus 9x squared gives me 10x squared plus 4y squared. And that's how I simplify that. So I'm not putting together the x squared and the y squareds. Okay, let's take a look at one that's a little bit more challenging, has some negative numbers. So we have negative 2x cubed plus 2x squared plus x cubed plus 7. Okay, so I have some x cubes, I have some x squareds, and I have just a number by itself. So what I'm gonna do to make sure that I keep track of actually combining the right things is any x cube I'm gonna just put one single line under, and the x squared I'm gonna put a double line. So I know I don't put those together, right? Because x cubed and x squared are two different terms. So let's put together negative 2x cubed plus x cubed. Remember, let's take a look at those outside coefficients. So I have a negative 2x, and then here, when you have just x cubed, there's really an imaginary 1 here, right? Because 1 times x cubed is the same as just saying x cubed. So what I'm actually putting together is minus 2x cubed plus 1x cubed. So remember, I'm just gonna keep x cubed there, and how do I put those coefficients together? Well, minus 2 plus 1, well, negative 2 plus 1 is just a negative 1, right? So I'm gonna actually write negative x cubed. I'm not even gonna write that 1 there. And then of course I have the 2x squared, but I have nothing else to combine it with. So I'm just gonna write 2x squared, and then the 7 all by itself, plus 7. So my new expression, once it's all combined and neatly combined, I get minus x cubed plus 2x squared plus 7. Okay, let's take a look at one that's fractions, because now, you know, there's so many different ways they can trick you up here. They can use x cubed and x squared, but they can also use fractions. So we have 1/3 x plus 3 over 7x. Important thing to note is the variable is the same, right? X and x. So I can put this together. I have to add the coefficients in front of it. So how do I add 1/3 plus 3/7? If this feels a little strange, make sure you go back to the algebra refresher on fractions. We talk all about the booty there. So if you skip that, go back. There's a funny little way that we learned how to combine these. So 1/3 plus 3/7. Again, my booty is not the same 3 and 7, so I gotta get the same booty. I'm gonna do 21 because 3 times 7. So I'm gonna make my common denominator 21 in each of these. And so how do I rewrite 1/3 with a common denominator of 21? Of course, I have to multiply by 7 in the numerator. To rewrite 3/7 with a denominator of 21, I have to multiply 3 by the numerator. So I get 7 over 21 plus 9 over 21, which is just 16 over 21x. Don't forget your x, right? You did all the work to add the fractions together. Make sure you don't forget that x. So many people do. So don't forget your x when you have fractions involved. Okay, so we're gonna pause there because what did we just learn? We learned what an expression looks like. We learned when can we combine expressions when we're adding and subtracting, and how, you know, x and x squared can't be put together. The next lesson, we're gonna be talking about multiplying and dividing, which is a little bit different, so that's why we're splitting it up into 2 lessons. So check out the problem set for these because they can get very tricky, and so you have to make sure you stay neat, you watch your negatives, and become really comfortable with working with fractions. So I will see you in the problem set, and then our next lesson is going to be on division and multiplication. All right, bye guys, see you there.